course timetables are an important part of a student's university experience, but there does exist a lot of problems with current timetables, from extreme gaps between classes all the way to technical electives conflicting with mandatory courses. The university's administration is aware of these scheduling challenges and works exhaustively to address them. Presently, our faculty uses a historical-based manual approach to schedule that includes a collection of Excel documents and a lot of interdepartmental communication and negotiation. While this is feasible, scheduling conflicts still tend to arise, causing frustration for both students and administrators. And the reality is that scheduling is a very complex problem that requires a lot of coordination. For us, the biggest allure to picking this project was how much, as students, we resonated with it. Our team wanted a project where we had decent access to our client and also a sense of ownership and the ability for creative freedom. And this project was exactly that.
So, how do we solve a scheduling problem? Most real-world scheduling problems are NP-complete. This means that there is no efficient algorithm that solves an arbitrary scheduling problem. But this also means that there exists a way to convert our course scheduling problem into one of the most well-studied NP-complete problems, Boolean satisfiability problem, or SAT. Given some information about courses, like number of courses per week and preferred time slots, the scheduler has to generate multiple schedules. I expected most of the work would go towards working on some complicated scheduling algorithm, but instead, most of the work revolved around transforming the scheduling problem and various constraints into a Boolean expression form. Then, this transformed problem is fed into an efficient open-source SAT solver that can find thousands of solutions in a matter of seconds.
In the beginning, most of the team was really new to the whole Agile process. Thankfully, we had a couple of members on the team who did have previous experience in Agile and really helped us shape the way we moved in the coming months. Since we were still getting to know each other and the project itself, we found great value in the earlier sprint reviews and especially the retros, where we opened up a table of discussion and solved problems collaboratively as a team. Communication with clients and users like Sam from EECS also became really important and allowed us to see the major pain points in scheduling. Initially, in our heads, it was only an optimization problem, and so we threw together some cool optimization solutions. But after sitting down with Sam, we came to know the real frustration was with the lack of time he has for scheduling. And so we took this feedback and went back to the drawing board to see how we can help him save time. As a result of these conversations, we were able to build our initial project mockup that we used as a jumping off point for the rest of the project and made sure to get continuous feedback from our users and clients throughout the process.
So, we knew that the problem we had on hand is solvable, and we knew how to approach it. We wrapped up the design phase by coming up with a pretty good overall architecture and user interface that enables the users to effortlessly get the solution from the solver. The project implementation is divided into 4 main components, where each component was assigned to a subteam. First of all, there is a front end, the code that runs the in-client browser when they open the application. All the code that's responsible for visual elements like lecture calendar, configuration buttons, etc. is in there. Second, there is the application backend. This is the central piece that holds everything together. It sends the front-end code to each new client upon connection, and also acts on client's behalf when responding to some particular requests. One such request can be to save the generated schedule so that it can be accessed later. A request like that would consist of sending the generated schedule to a database. Actually, anything that needs to be stored between different client sessions goes into the database. Finally, there is the course scheduler. Given some information provided by the client on the front end, like the list of courses and constraints, it generates schedules that satisfy those constraints and sends them back for display. Separating the project into 4 components was done to reduce the overhead from coordinating work on logically distinct part of the project, especially at the early stages of development. All 4 pieces can be tested separately, so it was straightforward to split the work and implement the components in small subteams.
As we started the new year, we were finally ready to start development full on. While we had successfully separated the different parts of the project into smaller subteams, like Max explained with the front end, the server, the course scheduling team, and so on, it quickly became apparent that there was still a lot of discussions we needed about the interfaces between those teams. Up until this point, aside from quick 15-minute stand-up meetings, we would only regularly have longer meetings with our subteams. Early on in January, we decided to hold our first hackstone. The idea was to work for 8 hours in one day, so basically just a mini sprint where we would all meet on campus, bring some coffee and bagels, and order pizza for us to share throughout the day. This ended up working out really well to quickly address any interface decisions that needed to be made, and additionally help the subteams actually make more progress, since subteam members could quickly help each other debug their issues. Also, it was a lot more fun to work this way. By this point, we were really hitting our stride with distributing tasks amongst ourselves and working in parallel. I was a part of the front-end team, and we chose to work in Angular. Angular uses a component-based system of development, which made it really easy to assign tasks based on the components that each developer would need to work on. It also made it easy to merge one another's code, since the developer's work was all stored in their own files. Angular also uses TypeScript, which is typed JavaScript. This was also very useful for our team for implementation purposes in order to create a front-end data model consisting of the course and curricula classes to help keep things structured well. But despite all this progress, we should have known it was too good to be true. Even with the help that the Hackstones provided us with addressing the interface concerns, this whole integration problem seemed no closer than it had been at the start of the month. You know, I've always wondered about what was the difference between the small hackathon-scaled projects that I've built and how the challenges in those projects are scaled up for larger projects. As far as development goes, it had been feeling quite linear up until that point. The bigger app meant that we needed more components, which directly correlated to a linear increase in development time. But once we had started adding in additional interfaces to the different parts of the application, such as between the scheduler and the server, between the server and the front end, between the server and the database, and so on, things were no longer linear. Every time a new interface design decision came up, now there was multiple different teams that we needed to consider to understand what everybody needed, what they don't need, in which format, when it needs to be saved, and so on. And so the technical MVP didn't get done for January. It didn't even get done in the first few weeks of February. Our team had been having consecutive Hackstone weekends for almost an entire month, and we still had integration decisions to make. Sometimes it was just that there was a new kind of bug or implementation challenge that we hadn't seen before. But the problem was anytime we needed to pass any data between two entities, which I hope you can imagine is fairly often for a web app, we had to address all of the same concerns between those subteams. We started calling this phase in our project as the pit of depression. We'd consistently been achieving our targets for where we wanted to be up until this point, and it was a pretty big bummer to be stuck on something that we all thought we'd have long figured out by then. Thankfully, our team was actually more prepared for this than we thought at the time. The lessons we had learned and the project management tools that we had picked up along the way in that first semester really helped us work through those February sprints. We developed a great routine that helped keep us on track, and working in Agile allowed us to quickly shift all of our focus to the integration. In the end, we had 2 long Hackstones during reading week that finally got us through to our MVP and lifted us out of the pit. Once we had our MVP, we took it back to our client, Mitch Burney, who works in the student advising office in Bergeron. He was really pleased with how far we had come and was really supportive throughout the entire process. However, along the way, we had realized that there was a couple of issues left for us. Specifically, finding ways to implement solutions with tutorials and labs being allowed to run at the same time was going to require some major data and design refactors. Mitch understood that with the remaining time, it may not be feasible to have a complete and polished product at the end, but agreed it would be nice to leave the project in a condition to hand off in the future. So we chose to attempt to do the data refactor and solve the lab tutorial issue. We got about halfway into that refactoring process when COVID hit, and in the end we decided to pull the plug on that. I'll show you where we left the app off. The main dashboard appears after the user logs in. The left-hand side of the screen shows the filtering options, while the right-hand side shows the main calendar display and the configuration bar. In this session, we can see that there are already some classes added to this session. The user can use the filter box to quickly hide or display different groupings of courses that have already had times associated with their classes. From here, the user can add new courses by using the Add New Class dialog here. I'll go ahead and add a new course right now. Once the course has been added, it will be shown in the list of courses. However, since it hasn't been assigned a time to run, it won't actually show up yet. Let's go ahead and fix that. The course scheduler takes in courses set up under different groupings called curricula. A curricula is the set of courses that a student should be able to take at the same time. So for software engineering, we have the complete list of courses they need to take here. Let's add that elective we just made to it as well, since we want to avoid having core courses conflict with electives. After running the scheduler, we can see that the courses have been shifted to remove any conflicts between them.
Over the course of 8 months, we have condensed our Capstone experience into 3 main lessons. The first one, starting from scratch is not recommended. Scheduling is not an easy job which involves many department and register office. Ultimately, reducing the scope of our project and taking advantage of existing solutions helps save our time and design power. From the project management point of view, once we are comfortable with the team and resources, often enough we tend to overestimate our speed and set goals that are too high. Allow yourself to be a little skeptical because most steps are more achievable than a big jump. The last lesson is our teamwork. Each member in our team possesses unique skill and talent. By allowing everyone to take ownership for each deliverable, the work is divided evenly in the long run and the quality is also improved. During the implementation phase, the team constantly went through multiple challenges and our original business goal became more unattainable, and so we agreed to leave out a handful of features that were initially in the design. As shown in our demo, the spare current version is a publicly accessible software where the user is able to produce the optimal schedule from the given input data and constraints. It captures the main goal of our project, but isn't yet a seamless experience nor sellable standalone product. Finally, we have reached the end of our capstone. Thank you so much for watching. We hope you enjoyed this video. From Team Spare, we would like to congratulate you on finishing your final year at university, and we wish you all the best success for your future career. Stay awesome, stay genius. Goodbye.